All right, so for homework, you had to simplify these imaginary constructs, right? So again, you're just combining like terms essentially. The main thing you have to worry about is the signs, right? So just be careful there because that's where a lot of times most of the mistakes happen. All right, so this one, the first one, was pretty straightforward because you're adding, right? So you just have to combine terms. So for your real part, you're going to have the 13 plus -5. So that's going to get you a positive 8. And then you have a -2i plus 6i. So 6 minus 2 gets us a positive 4i. So your first answer should have been 8 plus 4i. For number 2, you're subtracting. Okay, so again, however you've done combining like terms in the past, okay, stick with that. You can kind of just conceptualize it, right? So 3 minus 6, you can do it that way. Or you can distribute the negative like we did on Monday. So if you want to get rid of the parentheses, you would have the 3 plus 2i. There's nothing going on with that. Then you would have minus 6 minus 13i. Okay, so either way, just make sure that this negative gets distributed to the proper parts. Right. Another way to look at it is this is telling you to change the sign of anything in the parentheses there. So 3 minus 6 gets us -3. 2i minus 13i will get you -11i. All right, so your second problem, you should have -3 minus 11i. All right, now for these next ones, you had 3 parts. Right, so again, just be careful with your signs, really. So I'm going to write it so we don't have any more parentheses. So this 2 plus 4i, that's going to stay how it is. Distribute the negative in here. We have minus 10 plus 2i. And then that's a positive, so that's going to stay 4 minus I. So looking at the real part, we have 2 minus 10 is -8, plus 4 is -4. Looking at the imaginary part, positive 4i plus 2i is 6i. 6i minus I is a positive 5i. So your final answer is -4 plus 5i. Okay. For number 4, your first term was just pure imaginary. Okay, you didn't have any real part here. So I'll just write that down there because there's nothing outside of it. Again, we're going to distribute this negative. So this becomes a positive 2. That becomes -3i. Again, we have to distribute this negative. So I have now -2 minus 5i. I only have 2 real parts. I have a positive 2 and a -2, and they're gone. So our answer will be purely imaginary. 3i minus 3i, well, they cancel out. So all we're left with is -5i. All right, and the last one, let me write that at the top. So yeah, 5 minus 3i plus 4 minus I minus 7 plus I. All right. So again, the first term, we're not going to change anything. I can just get rid of the parentheses. That's positive. So that's going to stay plus 4 minus I. Now this is negative. Again, we distribute minus 7 minus I. 5 plus 4 is 9. Minus 7 is 2. Negative 3I minus I is negative 4I. Minus another I gets us negative 5I. And that was our last one. Okay, any questions about our homework? Okay.
Nope.
So today, briefly, we're going to talk about multiplication with imaginary numbers. All right, so here our main, we talked about this last week. I gave you part of the notes. When we multiply two imaginary numbers together, okay, we get I times I. Most of the time we write that as I squared. If I kind of dissect this, right, remember that our imaginary I is the square root of negative 1. So I squared would be the square root of negative 1 squared. And by inverse operations, the square root and the square cancel out, and we just get negative 1. Okay, so that's our main kind of takeaway that we're going to have to use, all right? That I squared is equal to negative 1. So there may be times where we have to kind of FOIL, right? So let's just kind of jump right into an example. All right, so here we have 2 minus I times 4 plus 3I. So here we're multiplying two binomials, all right? Even though I don't have a variable x, okay, these are technically binomials because there's two parts, right? It's our complex number, that's how it works. So when we do this, we still kind of follow the same rules, right? We have to FOIL. We distribute each part. So we set it up, right? We look at the 2 first, so 2 times 4, that's going to get us 8. 2 times 3i, right? Remember, we're just multiplying the number part, so 2 times 3 is 6, and the I comes along for the ride. So that was first and outer of the FOIL. Now we deal with the second term here, the negative I times 4. Well, that's just going to be negative 4i. Now here's where we got to be careful. Negative I times 3i, it's going to change to negative 3i squared. Right? If you're multiplying two binomials and each of them has an I, that I squared is going to pop up somewhere. All right, so now all we have to do is simplify. Our final answer should be a complex number. Okay, it should look like that, a plus bi. So right now the 8 is going to stay by itself because I don't have any other constant terms. All right, so that's going to stay 8. Here we can simplify like we did for homework. 6i, a positive 6i minus 4i will get us positive 2i. But now what happens here, I'm going to replace this I squared with negative 1. So this becomes minus 3 times negative 1. Okay, so again, I substituted in negative 1 for that I squared. So that's going to change some things. Okay, out here, it changes the sign of this -3 to +3. And we can combine one last term. 8 plus 3 is 11 plus 2i. And that would be our final answer.
So when you're changing the imaginary I, you have to drop the exponent.
Yes, yeah, but only for the I squared part, right? Once you
Okay.
change it to -1, you don't need that exponent anymore. Yep.
Right.
Okay, but those i's that are by themselves, you just combine and you leave them alone after that. All right, let's do another example. All right, so I'm going to give you guys some time to think about this on your own. Actually, no, this one we're going to do together because this one's special. Okay, here I'm going to introduce something that we're going to talk about a little more next week, but I want you to look at it, to see it now. So here we have 3 plus 2i times 3 minus 2i. There's a special name for these. If you notice, right, the terms are the same. The real part and the coefficient for the imaginary part, they're the same number, but we change signs from positive to negative. We call these complex conjugates. Okay, and they're an important part in imaginary and complex numbers, because again, something special is going to happen when we do this. All right, so let's FOIL these and let's take a look. You do the first, 3 times 3 is 9. The outer, 3 times -2 is -6i. The inner, positive 2 times 3 is positive 6i. And then the outer, we get -4. I times I gets us I squared. So here, because the way this is set up, where this part is positive 2i and this part is -2i, when we FOIL these two inner terms, we'll eliminate each other. Okay? And that will always happen as long as we have this complex conjugate set up, all right, where the sign is different. So we just have to be careful with this part. So that 9 is going to stay 9 for now. Now, using what we did before, I squared is -1. So this -4 is going to change to a +4. And then we just add those together, and we get 13. And so again, I'll just put it down here. This is -4 times -1, right? Which gets us the +4 there. All right, so next week, what we're going to see is we're going to have to use complex conjugates to help us simplify. All right, and then you may see an example where we just kind of have to do a regular distribution. Okay, so if you have just a single number on the outside, right, you would just distribute that inside, right? So you would have 10 minus 15i, right? So just be careful if that's an imaginary number on the outside then, because that would change the real part to imaginary. This would become 10i, and then the imaginary part, because we're multiplying it by another imaginary part, becomes real. Right? And then you would rewrite it in standard form, so you would have the 15 plus 10i. All right, so again, remember that this is negative, so that's going to change the sign. Okay, again, if you get comfortable enough where you can kind of see that, you can keep doing that. In the meantime, I recommend that you write it out step by step.
Can you do more examples of the first one? Just like one more example.
Like that?
Yeah.
Okay. Actually, let's do this. Let's do. Okay. So 4 plus 2i squared. Now, I say this all the time. Be very careful. This doesn't mean you're doing 4 squared plus 2i squared. You can't distribute the squared to both of those, right? Because of the addition sign. Anytime you see this, please rewrite it as this times itself. Okay, so let's take a look at this now. 4 plus 2i times 4 plus 2i. Okay, so 4 times 4, 16. 4 times 2i, yep, 8i. Sorry, had a little brain fart there. 2i times 4 is another 8i. And then 2i times 2i will be 4i squared. All right, so I'll do it in steps here. So we still have that 16. I can combine these two to give me 16i. And then this will be 4 times negative 1. Okay, so again, here I just changed the I squared to negative 1. Right, no more squared, just a straight substitution. So just to rewrite it, 16 plus 16i minus 4. And then your final simplification, you would do the real part. 16 minus 4 is 12. And then we still have the 16i. Right, so our main takeaway here is when we do this, we get the I squared. And we don't like that. So we replace the I squared with negative 1. And we continue to simplify. All right, any questions?
Nope.
All right.